Hello and welcome to our DP2 presentation. We are Dungeons and Variables. My name is Candace.
My name's Tommy. And I'm Caleb. So for our project management update, we have continued to monitor our progress through this Gantt chart. For more information about the first design phase, you can check out our first video. But for this phase, we've completed intellectual property searches, concept generation and testing, project architecture, and industrial design phases that will all lead into design phase 3.
For intellectual property, we have a couple of patents to explain of what we have stemmed some of our ideas, our design ideas from. The first patent is the toy tower construction, which was signed on March 24th, 1925. The toy tower is used in connection with electrical power systems and lighting systems, so that's basically the main idea of the patent. This patent has expired, but our idea, which stems from this patent, is that our structure of the tower will start off from being wide at the bottom and get more narrow as it gets closer to the top. And in designing our tower, it will have the crisscross structures in order to have more support and more sustainability, and to also create aesthetics. And then our second patent that we have stemmed our idea from is the conversion of rotational output to linear force, which was signed on August 15th, 1989. What this does, it converts rotational motion to linear motion by using a large gear in order to move 3 smaller gears, which turns it to linear motion. The idea is to connect our motor to the Arduino in order to have the ability to drive the motor and inverse it whenever we want to. And then also use gears to connect to the motor and hopefully connect that to the tower arm so that the user of the BRG is not moving the tower arm manually.
From our 9 obstacle ideas, our team came up with 6 individual concepts for the final design of the BRG. For example, concept B uses a springboard to launch the ball into a twisting tower, which then guides the ball into the velocity tunnels. These will teach such concepts as springs, conversion of energy between linear and rotational, and velocity. For our concept scoring phase of the design, our most important aspects that we wanted for the BRG was that it was an appropriate level of difficulty for the grade level, and that it had relatability to the subjects of math and physics and such. So we chose concept B for 3 main reasons. One, that it had the highest overall score in our concept scoring chart. Also, it seemed the most balanced between the different aspects. For our concept testing phase of design, we used a survey as our main method of determining the viability of our solution. So out of 6 surveys, we had 1 definitely purchase, 2 would probably purchase it, and the other 3 might or might not, or probably wouldn't purchase our product as is.
For our product decomposition phase, we had an overall black box of our BRG. As shown over here, a ping pong ball is designed to go into the BRG with a certain velocity, which also means it has a kinetic energy going in. Finally, the ping pong ball should also leave the BRG with a certain velocity, which also means it has kinetic energy as well. As shown over here, we have a more in-depth black box model, which shows the individual problems or obstacles in this case. For the first obstacle, we have, of course, kinetic energy going into the device, and then we have a user providing elastic potential energy in the form of a spring. That ball is then shot up into the air, which gives it gravitational potential energy, which is then go into the second obstacle, which converts that potential energy into kinetic energy, of course. And of course, a user provides a certain level, which your Arduino will raise a platform up to provide that specific kinetic energy value. On our third obstacle, the ball is designed to have a change of velocity, which will one path will match neither velocity to exit the ball.
For our failure modes and effects analysis, the example that we chose within our concept B is our twisting tower, which involves a motor. which gives our ping pong ball the height of 2 feet. So our potential failure mode for that would be a shortage in a wire. Our potential effects of the failure would be if the motor does not work because of that shortage in the wire. And then our potential causes of the failure could be the wire is bent. Our current detection method / design controls would be to test the motor every time we run the obstacle course, or every time we package it to send out to users. And then our recommended actions would be to make sure to not tamper with the wires and to not play with the wires until the motor is ready to be tested in order to package them up and send them to users.
As shown over here, we have a proposed loan payment cash flow diagram. We propose that VTEPs provide us $2,000 every quarter for about a year. Then for 2 quarters, no payments will be made, which allows us to gather money from the product to begin repayments. Finally, during the final quarters, we will provide $3,489.90 per quarter back to VTEPs. The loan I mentioned in the previous slide also has some pros and cons. In the pro side, our profit is nearly double with about $8,000 return, provide a maximum revenue of about $29,000. Of course, the loan is split up into 4 payments, which provides more safety for VTEPs so they can change the loan amount or cut it off based on projected performance of our product. Also, there's about a half a year or 2 quarters, which allows us to gain more money to begin repayments. However, on our cons, we also have a very high interest rate of about 15%. Also, we have to pay a very large overall payment, which turns out to be about $20,939, which is a lot more than which VTEPs pays us. However, this could also be a benefit to VTEPs.
So, at the end of design phase 2, we have concluded that our design does not infringe on relative patents thus far, and that out of the 6 concepts we generated, we have chosen concept B. Also, we have a feasible economic plan that we feel wouldn't be too difficult for VTEPs Inc. to agree with. And finally, we hope to make improvements on all of our designs as we move into design phase 3.